This video is aimed at those pupils aiming for a grade 7 in mathematics. The topics identified in this video are those that are key to achieving a grade 7. I've not covered everything in the topic, but the questions have been chosen to bring out some key points. You may need to go away and revise the topic further, but this should be good for last minute revision. Question 1. Quadratic sequences. Write the first 5 terms of this sequence. So to find the first term, we substitute n is 1. So we do 1 squared plus 2 lots of 1, which is 3. Take the second term, we do 2 squared plus 2 lots of 2, which is 8. The third term, we do 3 squared plus 2 lots of 3, which is 15. The fourth term, 4 squared plus 2 lots of 4, which is 24. And to get the fifth term, 5 squared plus 2 lots of 5, which is 35. Find the nth term of this sequence. Now we can tell it's a quadratic sequence because it doesn't go up in a linear fashion, it doesn't go up by the same amount each time. So to find the nth term of a quadratic sequence, the first thing we do is find the second difference. So the first difference, the first one is going up by 10, and then 14, and then 18, and then 22. So the second difference is going up by 4 each time. So once we've found the second difference, we half this to find the coefficient of n squared. So half of 4 is 2. So this is going to be the 2n squared sequence. Now, once we've noticed the 2n squared sequence, we'll write out the sequence 2n squared, which will be the quadratic part of this. So 1 squared and then doubled is 2. 2 squared and doubled is 8. 3 squared doubled is 18. 4 squared, 16, doubled is 32. And 5 squared doubled is 50. If we subtract this from the original sequence, that will take out the quadratic part of the sequence. So we'll be left with just the linear part of the sequence. So I've done 3 take away 2 is 1, 13 take away 8 is 5, 27 take away 18 is 9, and so on. If we look at this sequence now, 1, 5, 9, 13, 17, it's going up in 4s, so it must be the 4 times tables, so 4n. But the first number in the 4 times tables is 4, and ours is 1, so I need to subtract 3 from that. So the linear part of this sequence is 4n minus 3. So altogether, the quadratic part is 2n squared, and the linear part is 4n minus 3. So the overall nth term for that quadratic sequence is 2n squared plus 4n minus 3. Standard form. Really important you can do this without a calculator. So if you put it into a calculator, just type it in exactly as it is on a calculator paper, but on a non-calculator paper, we need to use a bit different method. So the way we do it is we group the 3 and the 4 together. So we're going to do 3 times 4, and we group the powers of 10 together. So 10 to the power of 5 times 10 to the minus 2. Now 3 times 4 is 12, and 10 to the power of 5 times 10 to the power of minus 2, we add the powers, so 5 add minus 2 is 3, so we times 10 to the 3. Now it's really important that standard form is between 1 and 10, so if we make that 1.2, I need to change my power to 10 to the power of 4. With division, we do exactly the same, so we're going to do group the 4 and the 8 together, so we're going to do 4 divided by 8, and that would be still times 10 to the power of something, but then we need to divide the powers as well. So 10 to the power of 8 divided by 10 to the power of minus 3. Now 4 divided by 8 is 0.5, and 10 to the power of 8 divided by 10 to the minus 3, we subtract the powers. So 8 subtract negative 3 is 11, so that would be 10 to the power of 11. And again, in standard form, it's got to be between 1 and 10, so I'm going to change this to a 5. So I've times that by 10, so I need to reduce my power by 1, which will be 10 to the power of 10. Proof. So it says prove that the sum of 3 consecutive integers is always a multiple. Now I've chosen quite an easy one just to show you the basics of this, but if you just read the sentence really carefully and set it up as exactly as it says and follow these same steps through, it will give you the final answer. So 3 consecutive integers, so an integer is just a whole number, so I'm going to call the first one n. To be consecutive, the next one will have to be n plus 1, and to get the third one, that would have to be n plus 2. And it says we're finding the sum, so that's why I'm adding them. It may say find the product, that would mean multiply, etc. If we simplify this through, we've got 3n's plus 3, and then it says prove that it's always a multiple of 3. So a multiple of 3 means it'll be 3 times something. So if I factorise this and pull out a power of 3, then that will show us that it is in the 3 times table. So because I could pull out a factor of 3, it must be in the 3 times table. So therefore, those 3 dots mean therefore it's a multiple of 3. Another area of proof is in shapes. So in this one, we're going to prove congruence. So it says M is the midpoint of AD. Prove that triangle AMB is congruent to triangle DMC. So congruent means exactly the same. Now, when we're proving congruence, we can show that the triangles are either SSS, so all 3 sides are the same, ASA, so you've got an angle, a side and an angle that are the same in each, SAS, so side angle side, or right angle hypotenuse side. So if it's a right angle triangle, you must have the hypotenuse of the side the same as well. So in this one, I'm going to show that angle CMD, so C to M to D is this one here, is equal to angle AMB, which is this angle here. And I always state why. So as they are vertically opposite. I'm then also going to prove that CDM, so angle CDM, so C to D to M is this one here, is equal to angle MAB, so M to A to B is this one here, as they are alternate. I know they're alternate because these lines are parallel and this is a straight line crossing them. I also know that AM is equal to MD, as it's stated in the question, because M is the midpoint, so you can just put as stated. And then we need to show that we've proved that they are congruent. So I've proved that they've each got 2 angles of the same and the side between those angles. So therefore they are ASA and congruent. Coordinate geometry. So this is where we're finding equation lines, etc. with coordinates. So it says find the equation of a line joining 2, 7 and 5, 13. So the first thing we need to know is the general form of a straight line is y equals mx plus or minus c, where m is the gradient and c is the y-intercept. So the first thing I'm going to work out is the gradient. The gradient is given by the difference in y divided by the difference in x. You might have seen that written as y2 minus y1 over x2 minus x1. So y2 is 13 and y1 is 7. I'm going to divide that by x2, which is 5, and minus x1, which is 2. So that gives me 6 on the top and 3 on the bottom, so the gradient must be 2. So I know that my equation of this line is going to be y equals 2x plus or minus something on the end. Now I've got that, I can substitute in one of the 2 points, so either 2, 7 or 5, 13. I'm going to substitute in 2 and 7. So 2 and 7 means when x is 2, y is 7. So if I put y is 7 when x is 2, I can now work out what c must be. So that's going to be equal to 3, because 4 plus 3 is 7. So if c is 7, my overall equation is y equals 2x plus 3. We can also look at finding midpoints and perpendicular lines. So the midpoint, find the midpoint of AB. I've kept the same coordinates here. So to find the midpoint, to find the x coordinate, we're going to look at adding the 2 x coordinates together. So 2 add 5 and half in it, which gives me 3.5. And to find the y coordinate, we're going to add the 2 y coordinates together. So 13 add 7 and half it, which is 10. So it will be at 3.5 and 10. It says, hence find the equation of the line which is perpendicular to AB and goes through the midpoint. So we've already found the equation of the line AB, because we did that in the first part. That's y equals 2x plus 3. We just need to find the one that's perpendicular to that. So a perpendicular line will have the negative reciprocal gradient. So it's going to be y equals minus a half. So the reciprocal of 2 is a half, and I'm going to change the sign to a minus. So that's the gradient of this one, and again I need to find that number on the end, that plus or minus c. I can then substitute in the values that of the midpoint, because it needs to go through that. So when x is 3.5, y is 10. So I'm going to put 10 is equal to minus a half of 3.5 plus or minus c. So I end up with 10 is equal to minus 1.75 plus or minus c. So if I add that 1.75 to the other side, that gives me that c must be 11.75. So my overall equation is y equals minus a half x plus 11.75. Estimation and bounds. So when we're estimating, we've always taught that you should round to one significant figure, and this is an example of that. However, in the new spec, you are looking at using numbers that are going to make it as easy as possible for you. So they started putting in multiple stepped estimations. So don't be worried about using one significant figure and it not working out. If you need to use two significant figures, it makes it easy for you, and you do whatever's easiest for you. But in this one, we're going to look at using one significant figure. So 25.7 would go to 30, 234 would go to 200, and 0.49 would go to 0.5. So to work this out, 3 times 2 is 6, and add 3 zeros, so 6,000 divided by 0.5. Now, to do this one, either you need to know that there's two 0.5s in every whole one, so divided by 0.5 is the same as doubling, so that's 12,000. Or if it was a more difficult decimal, I would times top and bottom by 10 to get rid of the decimal place and end up with 60,000 divided by 5, and then you can use the bus stop method or whatever you need to do to get that division done. Part B, a number y is rounded to two significant figures, to 260, write down the error interval. So the numbers that must have rounded to 260 are 255 and 265. Now, y could have actually been 255 or bigger, because 255 would have rounded to 260. It can't have been 265, because that would round up to 270. So we just put the less than sign there. Make sure you get the signs the right way around. It's really important that it's less than 265, but greater than or equal to 255. Probability. So a bag contains 5 red and 7 yellow sweets. Julie takes a sweet at random and eats it. So that's really important. The fact that she eats it means that it's not going back in the bag. Then takes a second sweet and eats that. Find the probability that she eats 2 yellow sweets. So first of all, for the first one, probability of getting a red is 5 out of 12. And probability of getting a yellow is 7 out of 12. And then for the second sweet, if you've already eaten a red, that means there's one less red, so it's now going to be 4 out of 11. But there were 7 out of yellow, so that'll be 7 out of 11. And then if you've already eaten a yellow first, probability of getting a red next would still be those original 5, but out of 11. And getting a yellow next would be 6 out of 11. Now we're only actually after this branch here, because we want yellow. So you multiply down the branches, so it's 7 twelfths times 6 11ths, which is 42 over 132. Now, if it asked for probability of getting 2 sweets of the same colour, for example, you'd work that one out, and you'd work out red, and then add them together. So you'd multiply down the branches, and if there's multiple branches that you've had to work out, you then add those together. Quadratic. So I've chosen this question because it's quite in depth. It's got all the different parts of graphing a quadratic. So it says, sketch the graph of y equals x squared minus 6x plus 8. Label where it crosses the y-axis, the x-axis, and the coordinate of the vertex, or otherwise known as the turning point. So first things first, the easiest one to do is where it crosses the y-axis. So it will cross the y-axis when x is 0. So when x is 0, y will just be 8. So it's going to cross the y-axis at 8. Then the next easiest one to do is find out where it crosses the x-axis. So to find out where it crosses the x-axis, we factorise it. So that's going to factorise to x minus 4, x minus 2. And then and make that equal to 0, because when that y is 0, that'll be where it crosses the x-axis. So to make that equal to 0, x must be either plus 4 or plus 2. So it's going to cross the x-axis at 2 and 4. And then to find the turning point, we need to complete the square. So to complete the square, we look at this bit first, and we look at the minus 6x, and we half that to get minus 3. So we're going to have x minus 3 squared. Now that alone would expand to give us x squared minus 6x, but plus 9 in the end. We've got this first bit correct, but we need to get this bit correct, so we need to take one off. So when we complete the square, it will give us that. So that is what we've got for the original equation. The whole point of completing the square is because x minus 3 squared must be positive. So the smallest this can get is when this part is 0, because otherwise it will be positive. It can't ever be negative. So when this bit is 0, x would be 3, because 3 take 3 is 0, and that would give us that y would be minus 1, because if that bit's 0, y would just be left as minus 1. So that tells us the turning point, because that gives us the minimum point of that equation. So now I can draw it. My graph is going to look like this. This point here, maybe could have been done a little bit higher up, but I'm going to label it as 8, and that would be absolutely fine. This would be at 2, and this would be at 4. And then the turning point just here is at 3 minus 1. And you can either label that on the axes, or just put the coordinates at the turning point. Simultaneous equations. So simultaneous equations come in more than two forms, but the main ones are where we've got an x and a y, or we can actually have quadratic ones as well. So the first one, which we'll be most used to, when we've got two linear ones, x and y. The first thing we need to do is make either the x's or the y's the same. You can choose whichever one you wish, but I'm going to make the x's the same in this one. So I'm going to multiply the first equation by 3, and that will give me 6x plus 15y equals 24. And I'm going to multiply the second equation by 2, which gives me 6x plus 14y equals 22. Now, so long as you multiply all the coefficients by the same number, that will keep it fair, because multiplying it all up will just give a different multiple. So we've not changed what the answers are going to be. And if the signs are the same, we subtract them. So 6x take away 6x will be nothing. 15y take away 14y will leave me with just y. And 24 take away 22 will give me 2. So y is 2, so nice and easy one there. There's not even a multiple of 2 to go at, and there's no negatives. Be really, really careful if it's a negative or ends up with a decimal. Now I know that y is 2, I can substitute that into one of the equations. I'm going to choose to put it into the first one. So I'm going to do 2x plus 5 lots of y. Now I know that y is 2, gives me 8. So 2x plus 10 is 8. So 2x must be minus 2. So x must be minus 1. So our values of y is 2 and x is minus 1. If we've got a quadratic, they tend to be given in the form y equals x squared, etc. And you'll be given a second linear one where y equals as well. If a second one is not in the form y equals, you need to rearrange it into that form and then substitute it. So because they're both equal to y equals, we can put both the right-hand sides equal to each other. So all we're going to do is put 6 minus 2x equal to x squared minus x minus 6. And then to solve the quadratic, we'll just get it equal to 0. So I'm going to take the 6 on and the minus 2x on the other side. And that will give me x squared plus x, because I'm adding 2x's to that side. And then minus 12, because I'm taking another 6 off. And then we can just factorise to solve. So that would be x plus 4 and x minus 3. And to make it equal to 0, x must be minus 4 or plus 3. Now, once we've got the x values, don't forget we still need to work out the y values. So substitute x is minus 4 into one of those. I would recommend putting it into the linear one. So to work out y, you do 6, take away 2 lots of minus 4, and that would give us that y is 14. And in this one, substitute that y is 3, x is 3, and that would give us that y is 0. So you've got two answers, minus 4 and 14, or 3 and 0. Direct proportion. So with direct proportion, the method that you use each time is exactly the same. You just need to ensure that you read the question really carefully. So it says A is directly proportional. So I'm going to start by writing this down. So A is directly proportional to the square of B. So that means we're going to be squaring B. When A is 144, B is 6, find equations for A in terms of B. So from here, we now change the proportion sign to an equals and understand that that would mean that b squared will be multiplied by a constant, the constant of proportionality, and we call that k. To work out what k is, we substitute our numbers in. So a would be 144 when b is 6, so 6 squared. So that'd be 144 divided by 36 to work out k, and that will give us k as 4. So that gives us a formula that a is equal to 4b squared. Once we've got that, part B and part C will usually be using that formula. So it says find A when B is 8. So nice and easy. So A would be 4 lots of 8 squared, which is 256. And then on part C, it says find B when A is 36. So this one we're going to have to do a little bit of rearranging for. So I'm going to divide by 4, which will give me 9. And then I'm going to square root. And don't forget the square root of 9 could be plus or minus 3. So 3 squared is 9, but also minus 3 squared is 9. So on the last set of papers, I think there were 3 marks throughout all 3 papers for knowing that the square root has a positive and negative answer. The next really important part for the higher paper is rearranging formulae. Now, rearranging formulae when there's only one x is quite straightforward. Just follow BIDMAS and undo that. But getting a grade 7, the most difficult part is when the letter that you're after, in this case x, occurs twice. So we have to use a little trick and get all the x on the same side and factorise. So the first thing I'm going to do, because there's a fraction, is I'm going to get rid of that fraction by multiplying both sides by x minus 3. So in effect, taking x minus 3 into the other side up there, and it becomes 3x plus 4 on this side. I'm going to expand the brackets, and I get xy minus 3y is equal to 3x plus 4. And I'm going to get all the x on the same side, so I'm going to take this 3x on this side, I'm going to take the minus 3y on this side, and I get xy minus 3x equals plus 3y plus 4. Now this is where the trick comes in. I could factorise this left hand side and to get x out of it. So I could factorise that to be that. And now I've only got one x that I need. And x is being multiplied by y minus 3. So to get x on its own, I'm going to divide by y minus 3. And that's rearranged for x. Circle theorems. So there are lots of circle theorems, and on the next slide I've got all the circle theorems there for you to revise. But I just pulled out a couple of questions that I thought were really key and come up quite often. So on this first one of the key circle theorems that we use is that the angle at the circumference will always be half the angle at the centre. So we can see here that because this angle has been created from the same arc, the one at the outside will be half the one on the inside. So this angle here will be 148. And I could take that off 360 to find that x is 212. So x is 212. And then from there, it's a 4-sided shape. So we know that all the angles inside a 4-sided shape or a quadrilateral should add up to 360. So I'm just going to do 360 minus that 212, the 20 and the 74. And that will give me that y is 54. On this next one, really important, we've got a diameter here, which would mean that this here is 90 degrees. However, we're not actually using that in this one, so it can be, sometimes you can look at circle theorems and you can know something, but you actually don't need it. What we're actually using here is, and there's a part missing from the question when I wrote this, I apologise for that. I should say that E is at the centre, that's really important. And since E is at the centre, that makes this and this a radii. So that means that that must be an isosceles triangle. So if that's 30, I could work out A and B by doing 180 minus 30 divided by 2, which gives me 75. So A and B must be 75. And using the fact that radii make an isosceles triangle is really important. Lots of students miss that out. And if we look on the other side, I now know that that must be 15 because I knew that that were 90, but I didn't really need that because I can also use angles on a straight line there, so that must be 150. And because this again would be isosceles with this one, again that would be 15 as well. So D and C are both 15. Here are the circle theorems, so just pause the video and go through all those, make sure you learn all those. There tend to be multiple ones in each question, so just look for the key parts, write down as much information as you possibly can, and then you'll be able to work it out from there. Surds. So simplifying surds is quite easy. We look for a square number that goes into that. So the square number that goes into 18 is 9. So I can write that as 9 times 2. The reason for looking for a square number is that I can actually square root the 9. And the square root of 9 is 3. So that would simplify to be 3 root 2. Hence means using what you've just worked out. So hence, simplify this. So the bit that I can use there is that root 18 is 3 root 2. I can simplify root 8 because that is 4 times 2 and that would give me 2 root 2. So I can simplify that. And root 200 is 100 times 2 and square root of 100 is 10, so that would be 10 root 2. So using what I've done in part A and simplifying root 8 and root 200, I can get that. Simplifying further, on the top I would have 5 root 2 and I'm dividing that by 10 root 2. Now root 2 divided by root 2 will cancel out and 5 divided by 10 is just a half. So that simplifies right down to just a half. You can also be asked to expand brackets, both linear ones like this or quadratic ones where you've got two sets of brackets. Just do it in the same way as you'd expand a quadratic. So on this one, you do 5 times 2 is 10, and 5 times root 3 is 5 root 3. Nice and easy. Again, it says hence rationalise this, so we're going to be using what we've just done. So this is a big clue in what to do. When you're rationalising the denominator of a surd, you usually just multiply top and bottom by the same as the bottom. That's if the bottom is just a surd. But because we've got 2 minus root 3, to cancel that out, I need to multiply that by 2 plus root 3. And I'll show you why that works in a minute. And you can see that part A was a big hint to that, because we've actually already done that bit. So the top is going to go to 10 plus 5 root 3, because we've already done that. And on the bottom, when I expand that out, 2 times 2 is 4, so I'm going to do that times that. I'm then going to do 2 times root 3, which is plus 2 root 3. I'm then going to do minus root 3 times 2, which is minus 2 root 3. And then minus root 3 times plus root 3 is minus 3. Now we can see that these two bits are now going to cancel out. So I've got 10 plus 5 root 3 on top, and on the bottom, with those bits cancelled out, I've just got 4 take 3, which is 1. And that therefore simplifies right down to just 10 plus 5 root 3. Surface area and volume of a cone. So to work out the surface area of a cone, sometimes they give you the formula in the question, or certainly part of it. So here they give us a curved surface area, and sometimes they don't. So on the next slide, I've given you all the formula you need to memorise. But on this question here, I've chosen this one because L, the slant height, is not given to us, and we have to use Pythagoras. So we know that this is a right angled triangle because 9 will be the height. So we've got that L squared is equal to 9 squared plus 5 squared. So L will be the square root of 9 squared plus 5 squared. So L will be 10.295, and so on. Now, leave that in your calculator using the answer one, because we're going to use that in a minute. So to work out the surface area of this, we need to work out the area of the bottom, which is a circle, so pi r squared, and then the curved surface area as well, and that's pi rl as given. So we're going to do pi times 5 squared plus pi times 5 times is 10.295. Now, don't round that. You should be using your answer button there. So if you press ans, that'll put that bit in for you. And if you put all that in, you get 240.263 and so on. And then usually you'd round to whatever it asks you to do. So in this case, I'm just going to round that to 240, and it's centimetres squared, the surface area. To work out the volume, in this case I've not given it here, so you do need to know this one. The volume is a third pi r squared h. So in this case, we're just going to do a third times pi times 5 squared times 9. Now at this point you can just put it on your calculator using a fraction button for the third, or if you notice that a third of 9 is just 3. So I like to simplify at this point, which just makes it a bit easier to put into your calculator, which gives you the volume as 235.619 and so on. And again, just rounding that to 3 significant figures, because that's usually what they ask for, is 236, and don't forget it's centimetres cubed, it's volume. Now, they could ask you for a cylinder, a cone, a pyramid, and a pyramid is very similar to a cone. So all the volume of a cone is the area of the bottom times by the height and find a third of it. It's the same for a pyramid, but obviously the area of the bottom will not be pi r squared. And then you've got the volume and surface area of a sphere as well. They do like to put hemispheres in there, so you might need to half those, etc. So memorise those formulae. Hopefully you'll be given them in the exam, and just be ready to use them if it's a hemisphere, etc. You'd cut those in half. Fractions. Now, fractions is a big part of this, and all the way through school, you might have been taught one way of doing this, but they tend to put quite big numbers in on the higher paper. So I'm going to show you a method where we can do this without going to improper fractions and having really big numbers, which is where a lot of people make mistakes. So to work out this first one, I would separate this to be 5 plus 2, and then the 2/3 and the 3/7 do that separately. So 5 plus 2 is 7. And to add together these, I need a common denominator of 21. So that'll be 14 over 21 plus 9 over 21, which will then give me 7 and 23 over 21. Now 23 over 21 is the same as 1 and 2 over 21. So putting that all together, I'll get 8 and 2 over 21. Now the difficulty with this one is when you're subtracting. If I change this to a subtract, I can do the same thing. So I can do, so if I was doing 5 2/3 take away 2 3/7, in this one I would do the 5 take away the 2, and then put together with that the 2/3 take away the 3/7. So do these separately and then put them back together. So 5 take away 2 is 3, and 2/3 and take away 3/7. Again, we need a common denominator, so just the same as before, but now we're subtracting. So that would give us 5/21 in that bit. So altogether, that would just be 3 and 5/21. Now this bit can often be negative. If that's negative, all you do is take that off the 3, and you get the same answer. The next part for getting a grade 7 is converting recurring decimals. Now the first mark for converting a recurring decimal is usually for writing down what the recurring decimal is and calling it something. So we're going to call it x, and it's just proving that you know that 0.545 with a dot above it means the 5 only is recurring. So if you put in some recurring 5s, that's usually where the first mark comes from. Now the trick for doing this one is to get 2 decimals that have the same decimal places, then we can subtract them away from each other. So I'm going to multiply this by 10 first, which will give me 4.555. So the whole point of that is that I've now got all the 5s after the decimal point. And if I times that by 10 again, I get 100 x's, is 45.555. So now I've got 2 numbers where the decimal places are all the same. So if I subtract these away from each other, so 100x take away 10x is 90x, and 45.555 take away 4.555 will just give me 41. So all the decimal places will cancel each other out. 45 take away 4 is 41. And to get x as a fraction, I'll just divide both sides by 90. It's 41/90. Trigonometry. So with trigonometry, hopefully you've got quite good at using SOHCAHTOA. So make sure you are good at using that in its general form. But also to get a grade 7, you need to know the exact trig values for certain ones. So you should have a table in your revision guide of all the exact trig values, but I've got one here, which is one of the less used ones. So on this one, we'll try to work out x. So this is the opposite, and this is the adjacent. So we're going to be using tan, because we've got the opposite and the adjacent. So we've got tan 30 is equal to the opposite over the adjacent. Now, using the exact trig values, you should know that tan 30 is 1/√3, and that gives us x over 6. So to work out x, just multiply both sides by 6, and I get 6/√3 for x. So that would be on a non-calculator paper. On a calculator paper, you can obviously just use tan 30. The next one that we're going to look at is using sine rule. So this time we've got a non-right angled triangle. So sine rule is when we've got an angle with its opposite side. So this angle is linked up with that side, and this angle is linked up with this side. Okay. So what sine rule tells us is that a side divided by sin of its opposite angle is equal to the other side divided by the sin of its opposite angle. And again, you could use that for the third side if you had it, but we often only use 2. So to rearrange this, I would take the sin 43 and multiply on the other side. So I'm going to multiply by sin 43 and just type that in your calculator exactly as it is. You get x is equal to 5.538 and so on. And again, they usually ask for 3 significant figures, so that would be 5.54 centimetres. Now that's the sine rule. The other one that we often use is cosine rule. So that's a squared equals b squared plus c squared minus 2bc cos a. And that is for when we've got a triangle, and we've got, this would be the side b, this would be the side c, and this would be the angle a. And that would allow us to work out this side here. So what we're after this time is the 2 sides and the angle between them. So the 2 sides are these, and then the angle between them is this one here. So that's what you're looking for this time. So sine rule is when you've got opposites, cosine rule is when you've got 2 sides and the angle between it. Percentages. Another big part of getting a grade 7 is knowing the difference between simple interest and compound interest. So simple interest is where you just work out the percentage and just add it on every year. Compound interest is where you work out the percentage for the first year and add it on, and then work out the percentage of that new amount each year. Now the quickest way of doing that, so this one says £1,640 is invested in the bank for 3 years at 4% annual compound interest. So that's really important, it's compound interest. find the amount after 3 years. So if you start off with 1,640, you would multiply that by 1.04 to get a 4% increase. Then if you multiply that by 1.04, that will give you the amount in the bank after 1 year. To get the amount the year after, you times by 1.04 again, so you times that new amount by 1.04, and then to get the third year, you times that by 1.04. Now the shortcut for this is just to do 1,640 times 1.04 to the power of 3. So this is the number of years that it's in for, and this is the interest rate. And if you put that in to your calculator, you get £1,844.78 if you round that. The other big one is reverse percentages. So on this one, it says the price of an insurance policy is increased by 14% to £91.20. What was the original price? So if the original price we don't know, we'll call it X. But if we did know it, we'd times it by 1.14 to get a 14% increase. And that would give me the answer of £91.20. So to work out X, I'm going to divide by 1.14. So £91.20 divided by 1.14. And that would give me that X is £80. Transformations. This is the most popular question on hire, where you've got to do a double reflection and then describe what a single transformation is. So on this one, it says reflect shape A in the y-axis. So the y-axis is this one here. So this is your line of reflection. So it's 2 squares away. So you're going to reflect it to be 2 squares away. And that's going to go like that there. We'll call that B. It then says reflect shape B in the line y equals 1. So where y is 1 is this line here. So if that's y equals 1, we're going to reflect that down, and that will end up there, and that's called shape C. There should be bread and butter to you. This bit now is describe the single transformation that will move from A to C. So first of all, it's gone this way, and you can see it's a rotation. And the really important bit that most people forget is that the rotation is about this centre point where the 2 mirror lines crossed. So the first mark is for writing rotation. The second mark is for the angle and direction, but in this case it's 180 degrees, so we don't need a direction. And then it's for saying where it's rotated about, and the rotation point will be where the 2 mirror lines crossed. So in this case, that would be 0, 1. Histograms. So the really important thing about histograms is that we know how to work out the frequency density. Sometimes this column will not be given to you, so that won't be a clue. So you need to know off by heart that the frequency density is the frequency divided by the class width. Now the class width is the difference between these two numbers. So in this case it's 20. So 40 divided by 20 would give me 2 for the frequency density. This one's 20 apart, so we're going to divide by 20 again, which gives me, sorry, they're 10 apart, sorry, so we're going to divide by 10, which gives me 5. The next one again is 10 apart, so we're going to divide by 10, which is 5.5. The next one is 10, so we're going to divide by 10 again, which gives me 4. And then the last one is 50, so we're going to divide by 50, which gives me 1. Don't be worried if these give you decimals, okay? You always divide them by the class width. So for the first bar, we know that it's between 0 and 20 and has a frequency density of 2. So we draw the bar in there, so that's where the first bar goes. Now, the reason for the frequency density is that the area of that bar would give the frequency. So if it's 20 wide and 2 tall, 20 times 2 gives me 40, and that was the frequency. So a histogram is where the area of the bars gives you the frequency, and that's why we worked out the frequency density. So for the next one, it's between 20 and 30 and goes up to 5. So nice and accurately as you possibly can. Again, use a ruler, unlike me. The next one's between 30 and 40 and goes up to 5.5. So nice and accurately, that'll be 2.5 squares up and down to 40. The next one will be between 40 and 50 and is 4, sorry, that should be 4, not 40, and should be 4 tall. And then the last bar is between 50 and 100 and is 1 tall. And all the areas of those bars would give you the frequencies. Now, there's usually a lot of follow-on questions from these, so it might be work out so in this case it's talk about money, so the amount of money spent between say 10 and 50. So in which case you would work out the area of this bar here, this bar here, this bar here, and this bar here, all the way up to 50. Okay, so that's what you're working out. So you'd only get take half of that first bar. So look at the following questions. Another following question will be to work out the median. And again, that's quite a difficult grade 8 and 9 topic. So if you want to look at working out the median from a histogram, go away and revise that on Hecate or in your revision guide. Box plots, really important, and it should be bread and butter to you and give you really easy questions. I've chosen this one because it often catches pupils out when you're not given one of the values, but you're given the interquartile range instead. So you'll notice I'm giving the interquartile range on this bottom one. However, we are given the lowest mark, so it tells us that the lowest mark is 18. So the lowest mark is the first line. The highest mark is at 86. Now, the biggest source of losing marks on this one is not knowing what each square stands for. So you can see these 5 squares stand for 10. So each square is worth 2, so be really careful with that. The median is at 57. So 50, 2, 4, 6, 7 will be halfway up here. So again, you've got to be really accurate with that. The lower quartile is at 32. And then the upper quartile, we've not told, but it does say that the interquartile range is 38. So if we add these together, we'll get that 32 and 38 is 70. So the upper quartile must be at 70. So just be watch out for that. Now we join the upper quartile and lower quartile with a box, and the lowest value to the box and the highest value to a box with a line. And that would be your box plot. So just look out for ones where you're not given one of the values, you've got to actually work it out. Regions and inequalities. So on this, you just graph each of those different equations, remembering that if it's greater than or equal to, it will be a solid line, but if it's just greater than or less than, it's a dotted line. So it's really important on each of these, you'll see that none of them are equal to, so each of them will be a dotted line. So the first one, y is greater than minus 4. So y is at minus 4 is here. So the line that I'm after is across here. This is where y is equal to minus 4. And to be greater than minus 4, I'm going to be shading it above that line. So I like to put these little arrows on to remind me which side I'm shading. And then it says that x has got to be less than 2. So x is 2 here. So the line that I'm after is here. And again, it's a dashed line because it's just less than, it's not equal to. And to be less than 2, I'll be shading this side of it. And then y is less than 2x plus 1. So 2x plus 1 will cross the y-axis at 1. And then a gradient of 2 means for every one across, it will go 2 up. For every one across, it will go 2 up. Okay, so the line is going to go through there. And again, I'm going to plot all those points, but then I'm going to join them with a dotted line because it's not equal to. Okay, so we're going to join those with a dotted line. And then it says y has got to be less than that. So we're looking at the side where y goes lower. So it's going to be this side here. And then you want to shade in this region here. So this triangle in the centre here is what we're after. Last question is just transforming graphs. So I've kept it quite a simple one here just to show you 2 key concepts. So the thing with this question is that you've got to be really accurate. You can't just sketch and hope for the best. So it says, sketch the graph of y equals x squared minus 2. And as soon as you see that word sketch, people just draw it really inaccurately. You've been given points on the original graph, which is x squared. So x squared minus 2 will be 2 lower than that. So each point should be lowered by 2. So this point here needs to be lowered by 2 to here. This point here needs to be lowered by 2 to here. This point, sorry, I missed one out there. So this point here needs to be lowered by 2. This point here lowered by 2. So lower each point by 2 and then join those points up. So even though it says sketch, you've got to do it really accurately. The one that people get confused with is where they put the x minus 2 in brackets. So what that means is you're going to get the same value for x squared but 2 earlier. So instead of moving 2 to the left, which is what most people think, it will actually move 2 to the right. So on this one, again, you're going to take each point in turn. So I'm going to take this point here and I'm going to move it 2 to the right. So it's going to go to here. Okay. This original point is going to go 2 to the right. This original point is going to go 2 to the right. This original point is going to go 2 to the right. This original point is going to go 2 to the right. This original point, 2 to the right. And this original point, 2 to the right. And again, we've got to do each one in turn nice and accurately and join it up with a curve. I hope that's been useful to you. I know a lot of the questions I've just gone through really quickly, but we'll just pull out the key points. Please do go away and revise them in more depth if you're looking for the higher grades, but hopefully this should help you pull out quite a lot of marks from the last half of the paper and get up to that grade 7. Best of luck with your exam.